I will now like to invite Adam Churchill, the 12D manager at SCIRT, and his team to come up here and talk to you about how the rebuild and the future of our city is going. Thank you.
It's Sunday evening, and I'm at Christchurch Airport saying goodbye to my girlfriend. Not too sure when I'm next going to see her again. The next day, I'm at work in Auckland, and my boss taps me on my shoulder. I've got an opportunity for you to be the 12D manager at SCIRT, and it's in Christchurch. At the time, I didn't know much about what SCIRT was. I knew a little bit about 12D, but I was pretty keen to get back to my girlfriend in Christchurch. That night, I'm flying down to Christchurch, and the next day, I'm in a portacom packed to the brim with 60 people and not much air conditioning, who all had the same goal of creating resilient infrastructure that give people security and confidence in the future of Christchurch. My name is Adam Churchill, and on behalf of SCIRT as 12D manager, I'd like to thank 12D Solutions, Lee and Alan, for inviting us here to present. And I'd like to introduce you to my team here to present the road to success with 12D. Sam Check has been an integral part in the architecture of the 12D environment within SCIRT. Rosman Abdullah, without his dedication towards the training and the drainage part of 12D, it would never have happened. And last but not least, Charlie Dixon, with his motivation and commitment towards the roading and the implementation of 12D, it would never have run so smoothly. The Stronger Infrastructure Rebuild Team, rebranded SCIRT because of its mouthful, was brought together to rebuild the horizontal infrastructure of Christchurch damaged by the major earthquakes. It follows an alliance model that harnesses the expertise of the private and public sector, promotes information sharing and collaboration, and manages the many risks and opportunities that will develop as work progresses. The head contractual agreement within SCIRT is made up of even more acronyms. CCC, the Christchurch City Council; SERA, the Canterbury Earthquake Recovery Authority; and the NZTA, the New Zealand Transport Agency, are the three owner participants within the SCIRT Alliance. But there are 5 non-owner participants known as the delivery teams: CityCare, Fletchers, Fulton Hogan, Downer, and McConnell Dow. Within the SCIRT's main office, there are 180 designers made up of the City Council and 16 other consultancies. And below the slide, you'll see an acknowledgement of all the other consultancies that are working on the SCIRT rebuild. The timeline's very strict. SERA has given a deadline of 2015 to complete all the horizontal infrastructure. The interim alliance was signed on the 4th of May 2011, but it wasn't until the 1st of September that the alliance actually took effect. This was when the transition from the earthquake reactive work happened to the long programming of projects. The designers moved into their accommodation in October 2011, and at present there were 750 people within the entire alliance. To meet the deadlines, the construction companies needed a good forward workload, to work efficiently. There needed to be $340 million worth of design in the pipeline, and this ramp-up called for extra designers, and there was a plan to get the construction companies and construction staff up to 2,500. We need to spend about $40 million per month to make this target for this bow wave. To give you a scale of the damage, most of the areas around the river and the CBD were heavily damaged, and a lot of that red area there will not be built on due to the ground conditions. We have a lot of work to do. The horizontal infrastructure includes the wastewater, the stormwater, the roads, the reticulated water, retaining walls, all the pump stations and the bridges. And to put a cost into perspective, at the moment we've spent $225 million in the last financial year, and we're estimated to spend $447 million this financial year. A lot of the design at the moment, a lot of the work at the moment is getting done in concept and detailed design. As I said before, to get a good workload for the contractors. With a project this large, there's a lot of planning to do in how we deal with the data. And in regards to the design system within SCIRT, we wanted a field to finish approach. So GIS from council would get fed into a central engineering database. Survey would get done. The design would work on the survey and the GIS information and any other underlying information like CCTV and LiDAR. Once the design was finished, the construction would take place, then the as-builts of the construction, and that would get all read back into the central engineering database to get pushed back into GIS. The central engineering database is effectively a repository or a vault for all of the data. But we're dealing with so much data here, even the LiDAR itself is 5 data sets of 5 million points each. And the whole idea is that if we get all this survey information, all this as-built information into this database, we'll be able to get a 3D model of Christchurch in the roading and the drainage for the council. So it's a pretty big thing. The CBD was hit pretty hard in the February earthquake. So what we can use the LiDAR for is we've got pre and post earthquake, and we can do a comparison between those two to give us areas of shift. So this shows you in the purple is more than 0.3 of a meter of shift down. Red's 0.3 and it goes out from there to yellow at 0.1. So most of the areas moved by 0.1 at least. With the central engineering database holding all this information, when the design is happening, we can define a project area. This area will take a cut of the central engineering database, known as the master project. From this master project, all the designers that are working in this area will be able to share information from the master project. The idea is that at certain stages in design, the designs will then get pushed back into the master project to get shared to the other designers working in that area. that published information will also be able to get pushed back into the central engineering database, and we can use the GIS integration that V10 is able to use to push it into a SQL server, into GIS for our management. So our management can see where stages of design is happening. So why did we choose 12D? Well, it was capable of doing all the engineering necessary to do the horizontal infrastructure. It was easily customizable, but the main reason was it could deliver a field to finish approach. So we could have the GIS information, survey information coming in, we could do all the design, we could get the as-built into 12D as well, and then we could push it straight into GIS. So it's exactly what the council needs. It was the vision of the management team to get a product that could get this field to finish solution. But without a team and dedication of the Alliance, this would not have been so successful. And I will leave it up to Sam to show you what it took. Thank you.
Thanks, Adam. Hello again. The head is not because of the sun, but it's strange the whole way the Alliance works and the way all the companies that have been involved, the subcontractors, operate. I myself am not seconded to SCIRT. I work on a contract basis. And essentially what they ask us to do is leave our identity behind and become part of this big alliance. It's sort of similar to joint ventures, but on a much, much bigger scale. And they asking this of the subcontractors of the subcontractors of the subcontractors. And if you are the fifth man down the line and you're unlucky to get drug tested on a day, then you have to comply if you want to be on a job. But it is something that's necessary to get the job done, and it is a very interesting commercial environment we operate in. So when Lee was talking about closing the loop, Adam has showed you that the loop has been closed. 12D at SCIRT is essentially operating as an autonomous software that does the field to finish. It brings the data in from GIS, does all the work it needs to do, and publishes it back to GIS. When I was first approached, and that was by Lane Irwin, and he brought along Chris Scott, the survey manager at SCIRT. It sounded to me a little bit strange. They basically approached me and said, hey, look, we're going to build 3D electronic model of Christchurch. We will have no survey plans, no topo plans. It's all electronic data, all the stuff we've been talking about for years. It's all happening. It's all here. Are you on board? And tell you what, I was a little bit hesitant. I wasn't quite sure, is this possible? Is it achievable? Can we do it? And they left it till the second meeting to tell me, oh, by the way, we also have a few constraints. 120 users, most of them never seen 12D. You will get, plenty of time, 4 weeks to implement this. And then you got 12 weeks to train everyone. So at that point, unfortunately I said yes by then. I was sort of like, is there anything else, any other small print you forgot to tell me? And he goes, oh yes, there's the GIS thing. We need to talk to GIS. Oh, and the management wants transparency and visibility of data. So we need to publish. We need to publish your progress every month. Job gets published at preliminary stage so that the GIS guys can run their own assessments on how many projects are on what stage and how far along they are. Plus the added benefit is, of course, the fact that we can share the data between different jobs from the master project. So you can imagine why I was sort of reacting the mission. The mission was bloody difficult. But you guys, it's not impossible for a team. And a team is all that it takes. We had a big team that was put together within a couple of weeks. I remember the first time we sat in a room with both Charlie and Rosman, and there was 12 people, including them. They were all looking at me absolutely gobsmacked, like, what are you guys talking about? You want us to be part of what? You're calling us, because I rocked up and I said, you guys are the super users, you 12D super users. 5 of them put their hand up and said, I use MX, never seen 12D. So we basically explained to them, we're going to give them concentrated training and make them the super users as long as they are willing to be the go-to people, the ones that can learn quickly and can focus on helping others. And we had a big team of people that helped us to make this all possible. And these guys are the guys that tackled the customization project. Customization, well, we could debate it, but it's not an art. It's basically just a process of identifying standards, requirements, and outcomes to achieve the high quality design and greater integrity of data. However, the biggest difficulty was the time frame. And the outcomes and standards kept changing on us constantly. So we've said about having few small little goals to achieve with every single customization we're doing. What you see is what you get. Very typical of 12D. Intuitive, logical standards that users can follow, especially those coming from Civil CAD and Civil 3D and MX. Using simple terminology. I remember the very first meeting I had with these guys. They're really good, experienced designers, but I got confused. Oh, I lay my MC string and then I have an RD string and my DR string and my, oh gosh. You know, let's come up with some terminology here and make sure that everyone's singing from the same song sheet. And the last, we set up a names.4d file. We make sure that was set up early on, and everything that we do must be based on the names.4d file. And that allowed us all the automation within the software to achieve our goals. Developing the best customization is absolutely nothing if we can't communicate it to those 120 designers. Therefore, Charlie, as the implementation manager, together with the super users, have produced over 200 pages of documentation in that short space of time. And it's referred to by all the designers on a daily basis. So if you ever implement something in 4 weeks, it's all about documentation, documentation, documentation. Only after that could I go and spend my nights writing macros. And we went about streamlining the process. I can't remember how many macros we've written, it's over 20 or so. But essentially, macros are the one thing that allows us automated processes to happen. We've drawn inspiration from the inbuilt options, and if we couldn't run them in chains, or if we couldn't get the report exactly the way the TOC or the management or whoever else needed them, we wrote the macro and make sure that it happens. Publishing of data was the one most important thing that the management had. We've created a couple of macros that allowed us to publish data to the master, from the master to the CED, and the CED is synced up with GIS. Headed by the 12D manager, Adam, and the survey manager, Chris Scott, the team of super users have achieved all their goals in a super quick time. So if you ask me what it takes to set up a 12D model, it's a great bunch of people that are dedicated to the cause. So next you will hear how the results of this process have been used in our unique design aspects and how our roading and drainage is being designed. I'll call up Rosman to talk about drainage. Thanks.
Thank you, Sam.
Sorry, he works for Woods.
Yeah, it's on the name tag, don't worry. Now, prior to SCIRT being formed, I was working at one of the joint ventures that was dealing with emergency repairs for our infrastructure. It was about this time that 12D was announced as the design package for SCIRT moving forward. Now, Lane was down visiting and I overheard him talking about recruiting these 12D super users, and it got me thinking that 12D has many strengths when it comes to to drainage design, but equally Christchurch has a lot of unique, challenging characteristics. You know, we've got large catchments, flat pipes, deep pipes, and a lot of bits and bobs that sort of go with the networks. So it was really a no-brainer. I had to put up my hand and be one of these super users as a way of sort of making my mark at SCIRT. So fast forward a month later, and we're all at our purpose-built facility, which some people refer to as the nerd barn. And there's a couple of our finest engineers hard at work. So yeah, a quick count of there's about 125 designers. There are only about 5 of us that could actually use 12D. So we really needed to get our act together. We had, as was previously mentioned, we had a deadline of 12 weeks for designers to be productive. Now Lane and Dylan from 12D New Zealand, they're still present, but obviously they had other clients to look after, so it was really up to us to be able to help ourselves. That is me at the top, by the way. So what we did was we developed these shorter, more SCIRT-focused courses, and these would be about 2-3 hours per session, and that meant that it was minimal sort of disruption to designers' workloads. So obviously we had real projects to work on. It was really about teaching them 1 or 2 sort of safe methods to achieve their outcomes, because we all know that 12D has many ways to skin the cat, but we didn't want to overburden people with too much knowledge. So yeah, the key was to get these designers to learn to walk in 12D before they ran. Now, those 12 weeks, it was my full-time job to be a trainer, so I was doing several sessions a day of sort of the same sort of material, like Groundhog Day really. And yeah, I found it extremely draining, excuse the pun, but equally it was very rewarding just seeing the results, people actually learning things from me and being able to use 12D is very satisfying. And I also have a newfound respect for the likes of Lane and Dylan, who that's their bread and butter, and they do it so well. So yeah, big ups to them. Now, after the earthquakes, the way we dealt with our wastewater is that basically we were pumping our poo into your nearest river. So it was looking even more brown than that big river you see in town there. Our stopgap solution citywide was to line your streets with portaloos. Now, personally, I never actually used these. We opted for the other alternative, was to dig a couple of pits in your backyard. And one night I left one of these pits open and come out the next day, and there was a hedgehog at the bottom of it. But he's okay. I saw him playing in the snow this year. So again, going back to a couple of these wastewater network characteristics that our drainage has, you're looking at very, very large catchments serviced by a single pump station. Our, Christchurch being so flat, our pipe grades have to be as flat as they can be. You're talking about 0.22%, which just sounds crazy. So moving forward, the design standards were amended to basically create more resilient networks, should any future events occur. One of these amendments included the use of what's called the attractive force method, And that's basically a couple of formulae that size your pipes and also grade them, and it's very well suited to our large networks. But the issue is there's no software to date that can incorporate these formulae. But like we've said before, some of the real strengths that 12D has is its interface with other programs, so Excel being one of them. So all we had to do was build a spreadsheet with these formulae, use the drainage network editor to export all our data, run it through these formulas, and just read it back in, and yeah, there's your network designed. So it was actually quite painless once we sort of figured out what we needed to do. Now, not all of our networks are completely damaged beyond repair. Some of the pipes we have can be treated with innovative repair methods. So you've got lining, you've got replacement, or partial replacement, and also patch repairing. There was a real challenge on how to model and plot and quantify these easily, but through our customized drainage 4D lists, the use of notes in your drainage network editor, and falling back on our naming conventions, there was never any problem in the end. It was all a very sort of fluent process. Now in Christchurch, again, as I said, there's very flat pipes, there's also very deep pipes, and when they reach a certain depth, they're not actually practical to directly connect your laterals to. So what we have are called collector pipes that run directly above your trunk main. Again, it was very much a challenge to try and model, plot, and quantify these. In fact, it was a pain in the butt to begin with, but with some of the SCIRT talent, we could create a macro, and basically it allowed us to simply select our section of trunk main from manhole to manhole and apply your levels, your pipes, and your diameter of the collector pipe. Just press the button and it's all set. And you can see that those collector attributes actually show on your long section plots as well. So that saved enormous amounts of time, and particularly in drafting, you're probably talking about a good 20 hours a project, if not more. And last but not least, quantities. Our estimating teams require huge amounts of detail for us to provide them when it comes to pricing the job. They gave me a somewhat ridiculous wish list, which when I read at first I thought they were just crazy. You know, they obviously didn't understand how 12D worked, but I learnt, being forced to produce this information, I learnt a lot about how well 12D, again, interfaces, but also the wealth of information that these networks can contain. So in the end, it was really straightforward. You build yet another spreadsheet, export, press a few buttons, and you've got these detailed reports, which is just brilliant. It saves a lot of what we used to do was just, we have a few interns and graduates, so you just give them a set of drawings and just, you know, get them to manually run through it, and it's quite torturous, really. So now that we have all our people trained up and we've managed to innovate and create things to overcome these unique challenges of the urban rebuild, we're getting our designs out the door. So with our number ones and number twos sorted, it's time for me to hand it over to Charlie to talk about number 3 roading. Thank you.
Is this a normal situation? Flat grades 1 in 500 or 0.2%, property zones, stormwater pipes working and broken, retaining walls, ground settlement and the terrain is still moving. Designing roads is like surfing. You're constantly correcting your movements like the way we modify crown and cross-section crossfalls. Iteration after iteration. It's tricky being on a dynamic platform. It's designed in Christchurch 2012. Christchurch Infrastructure Design Standard and Construction Standards form the foundation for design infrastructure in Christchurch, which have been amended for the earthquake design. The assessment scope of roadworks is a street-by-street basis, a patchwork of varying treatment for curbs, channels, paths, etc. A lecturer once told me, road design is about drainage, drainage and drainage. One work package of 2 streets had further settlement ranging from 150 millimetres over the period between end of design and start of construction, approximately 3 months. It has been really important to design and do designs very, very quickly. Further to this is the uncertainty of roads that interface with residential red zones, the land that's uneconomic to repair. Green zone access through red zone streets highlight the difficulties civil designers are facing. Okay, oh, that's better. In that we need to minimise the cost but still achieve desired outcomes with less permanency. An example of this is where curb and channel is being replaced with swales, thus maintaining minimum levels for drainage and access. Our council requirement states a Camber Correction has to be applied to carriageway crossfall for drainage and safety purposes. Designers from outside the region and other countries who came to help may not have the knowledge of local requirements. Therefore, we have added a help icon to each toolbar. This will guide them through the design standards as well as workflows within 12D model. SCIRT has also developed a road quantity macro, which has been made for easy interpretation of quantities and allows for automation of time cost estimation. It is based on the inbuilt 12D option. However, it runs in chains and produces Excel-friendly reports. Just cut and paste to Excel and print custom reports as needed. The macro is customizable for different types of road designs or road treatments via chains, and has been placed on a special toolbar to aid this process. Quantities have never been easier. Not only have the flatter sections of Christchurch been affected, but also the hill areas. This highlights the further infrastructure damage, including the stormwater, the wastewater, the water and the roads. The total number of retaining walls in council database number 2,360. Of these, 716 walls have been identified as damaged by quake. Currently there are 53 projects totaling 103 walls. These walls range in 1 metre to 6 metres plus, and these will comply to the new standards. Varying terrain models pose different issues in engineering design. An example of a volcanic feature is the stone wall at Sumner Road, Littleton. The existing stone wall collapsed in sections. The walls were built by Scottish stonemasons who were able to cut 5 stones in a day that was supplied from a local quarry. The new walls will be designed with resilience and safety in mind, while also accommodating the demands of heritage listings, i.e. provision for stone facing. The wall is being constructed in 4 stages, a tricky design in that side roads and access ways also need to be factored into the design, and that ground anchors extend from face of wall for approximately 15 metres and into adjoining residential properties. This requires legal easements to be created, another component to the design process. The 12D design layout uses a series of hinges for each independent wall design, but still maintains one reference alignment for all walls. This makes identification easier for designer and contractor due to having one running distance. Other wall designs have used design chains to combine independent wall designs. This enables designs to be grouped to create one final function and to ensure any updates to separate walls are updated at the click of a mouse. We aim to improve SCIRT 12D systems and processes, that is, updating plot parameter files for drainage and roading outputs, improving quantity reports through client and user feedback, modifying 12D design processes in roading and drainage techniques due to finding more efficient methods, looking at new avenues where 12D could be useful, visualization 3D plans for communication to residents, geotechnical design, specific training and macros written to enable geotech engineers to automate existing processes that have been previously made by hand. So, upskilling the team and ourselves. You might have noticed in Sam's previous slides there was a little cone, crocheted cone. So I'm going to talk about that. How are people coping with earthquakes? Valerie is a librarian at Christchurch City Council Libraries, and to cope with the stress, she began to knit. Valerie started knitting orange covers for the road cones that sat outside the library. I brought one with me today, the desktop model. Before leaving Christchurch, Valerie sent me this note. Hi Charlie, all is well. I think the cone would love to go to the conference. Don't let it get too sunburnt. When I drive slowly past lots of road cones each day, instead of getting cross with detours and delays, I think, hooray, the roads and pipes under Christchurch are getting fixed. Valerie. The SCIRT 12D system is here. 3D electronic model of Christchurch is constantly being updated. Paperless design and a closed loop process. We now have 120 competent designers working with 12D model and training modules to bring on more designers in the future. Anything is possible with the right team. The future belongs to those who prepare for it today. Malcolm X. Before concluding, I'd like to thank you all for your support during these really shaky times. And I'd like to leave you with this short movie clip and enjoy the conference.
Well, thank you very much for the introductory talk. The guys obviously here for the 3 days, and it's well worthwhile getting them down and just to hear some of their personal experiences in Christchurch. I've been to Christchurch a number of times because this project came up, but by the time I got there, it was already not that long after, but they'd cleaned up all the streets, the buildings, most of the rubble was taken away, so you couldn't see the devastation. But it keeps happening again and again, so it's worthwhile, as I say, grab the guys and have a good talk to them. It's just how they live from day to day without any toilets, without any hot water, any cold water, having to go to the neighbour's house to go to the toilet or have a shower. So thanks very much for the SCIRT team.